Hello everyone, this is Kitish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2018. This paper is 1 hour 15 minutes long and it's tested on 4 main topics: energy, electricity, atomic structure and particle model. This paper has 7 questions in total and it's out of 70 marks. Let's have a look at question number 1. A student investigated. This question is actually on the topic of forces and it looks like it's a required practical on Newton's law. So it's a required practical question and it's to do with Newton's law, F equals ma, Newton's second law. So a student investigated acceleration using gliders, an air track and light gates. The air track reduces friction between the glider and the track to 0. Figure 1 shows the apparatus. So you have the glider and the car on top of the air track. This main bit is the air track, which is at the bottom here. So you've got the 2 light gates, one at the start and one at the end, and a string attached to a mass holder, which is going to pull the glider. The glider was released from rest and moved along the track. The mass holder hit the ground before the car passed through the second light gate. Okay, that means the force on the glider was not constant through while it was passing light gate 2. Which 2 statements describe the effect this would have on the glider? The acceleration would decrease to 0. The acceleration would increase. The acceleration wouldn't increase. It could actually decrease to 0 because there is no force acting anymore. If it hits the floor, the resultant force on it would decrease to 0. That would be correct as well. The resultant force will not increase. The speed would increase. And so it's options 1 and 3. This mass holder should not hit the ground before the car passes through the second light gate. Suggest one way that the student could stop this happening. You could move the second light gate closer to the first light gate, or you could shorten the string, or you can elevate the entire table. So any of those will be fine, but the first 2 is the best. Move the second light gate closer to the first, or shorten the string length. The student increased the resultant force acting on the glider by adding more masses to the mass holder. She calculated the acceleration of the glider for each resultant force. Each test was done 3 times. So you have a resultant force of 0.2, then 0.39, 0.59, 0.78, 0.98. You have 3 tests and the mean acceleration, and the first one has far too many decimal numbers than the rest. Okay, the student made 2 mistakes in the mean acceleration column. Identify the mistakes the student made. Suggest how each mistake should be corrected. So when we are recording data, we particularly learn this in A-level physics, not mainly in GCSE, but you have to know about this. So when we are recording data, it's always better to record all the data into the same significant numbers or same decimal points. This way, when you're plotting the points onto a graph, you're not going to have too many different significant figures to deal with. So this is actually incorrect. This should be in 2 significant figures. So I would put that as 1.3 rather than that entire number. The second one. So let's have a look at the data. They're all within the range of 1.2 and 1.3. Second row is fine. Third row is also fine. Fourth is all fine. Sixth. Okay. So this one looks too big as well. So they should have actually ignored it to calculate the mean, which would bring the mean to 6.4. Or was that correct? Is that mean correct? Let's double check the mean. So you have 6.4 plus 7.2 plus 6.4 gives you 20. Divide that by 3. So it is 6.67. So they have got that right. So we didn't find that 7.2 is actually correct. So the mistake, first one is 1.26667 meters per square is wrong, right? The correction should be give value to two significant figures. And the second mistake is 6.7 meters squared is wrong. Discard the anomaly, which was 7.2, and write that down. Anomalous result 7.2, and recalculate the mean, which will be 6.4. Write a conclusion for this investigation. So the conclusion is, what happens when the resultant force increases from 0.2 to 0.98? The mean acceleration also increases. Right? Resultant force is directly proportional to the acceleration. So how do we know that it's directly proportional? When I increase it from 0.2 to 0.39, which is nearly doubling it, the mean acceleration is also doubling. So the reason I can say that confidently, that when I double this resultant force by 2, the mean acceleration is also doubling, right? And when it goes from 0.39 to 0.78, doubled again, it goes from 2.6 to 5.2, nearly doubled again. This is why you could say that it is directly proportional. The student used a constant resultant force to accelerate the glider. The student changed the mass of the glider and calculated the new acceleration. She repeated this for different masses of the glider, keeping the resultant force constant. The results are shown in the table. Mass of the glider in kilograms. And you've got the acceleration. So as the mass increases from 0.06 to 0.14, the acceleration is decreasing, which is correct, because using F equals ma, mass is inversely proportional to the acceleration. Plot the results on figure 2. So at 0.06, so they have already given you the scales for the mass and the acceleration. So at first one is 0.06, 3.5, and that's 3.5 there. 0.08 is 2.6, so that's 2.5 and 2.6. 0.1 is 2. 0.1 is 2. 0.12 is 1.7. 1.7, and 0.14 is 1.4. That's 1.4. Draw a line of best fit. So here it doesn't look like that it's actually a straight line. So if I start from here, so it's definitely not a straight line, and I can't try and fit even if I wanted to. Let's see. So I wouldn't want to draw a line like that. Let's get rid of the line. It needs to be a curved line. So it has to be freehand. There you go. So in order to get the marks, the marking scheme says all points plotted within half square and a curved line of best fit. Describe the relationship between the mass and the acceleration. Now, as the mass is increasing, the acceleration is decreasing, which means it is inversely proportional. That brings us to the end of question number 1, and I will see you in question number 2.